Okay. The ions of X minus and Y plus are isoelectronic. It means they have the same number of electrons. It means X minus and Y plus, X minus and Y plus, equal number of electrons. Y plus, okay, equal number of electrons. So the total number of electrons for them is 10 electrons. How many protons are there? Okay, let's analyze. Let's start with X minus. X minus has 10 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now there is an extra negative charge up here, making this an anion. You know, negative charges are for electrons, positive charges are for protons. Because there's an extra negative charge here, it means that all these electrons were neutralized except one electron. That is why you're having one up here. There is one unneutralized electron. So there is one proton short. That's another way to put it. Is either you say there is one proton short or there is one electron extra. Okay. Now, it means we're going to leave this one electron extra and neutralize the rest. Okay. One there, one there, and one there. All right. Now, if this were to be a neutral X atom, if this were to be a neutral X atom, what would have been the number of protons? Now you know, number of protons don't change. Proton is atomic number because it is not a nuclear reaction. The number of protons don't change. You see, the number of protons here would still be the same. It is most likely that this electron was rather added. So electrons are added to form anions, which are negative ions, like X minus. All right. And electrons are removed so that there will not be an extra or excess positive to form cations, which are negative ions like Y plus. Okay. So what this means is the number of protons you're seeing here has always been the number of protons. Protons don't change. So let's just count 1, 2, 3, 4, 5, 6, 7, 8, 9. So X has 9 protons. Number of protons don't change. All right, let's go to Y. Y plus. Now we're told that they are isoelectronic. This word here means having iso, isotope, isomer, isoelectronic. Anything iso has to do with being the same. All right, they have the same number of electrons, and we're told 10. So we'll still make 10 electrons here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, one proton extra. So the protons are more than the electrons, and there's an excess proton, just one. They're more than by just one. So one, okay, and then we neutralize every other electron with the proton. So plus minus go, plus minus go, plus minus go, plus minus go. All right. Now we can now count the number of protons we have. 1, 2, 3. 1, 2, 3, 6, 7, 8, 9, 10, 11. Y had has 11 protons. So the reason is electrons are usually transferred out. All right, this is in and this is out to get positive ions. So this guy you're seeing here is the way he is because an electron must have been lost. We already know that number of protons don't change because that would mean changing atomic number. And atomic numbers are like the ID card of atoms. So that means you are changing what the atom actually is, which only happens in nuclear chemistry and not in normal electronic chemistries like this. All right, super easy.